the very first thing you want to do is you want to identify, well, actually the very first thing you want to do is, if possible, factor. So on top, there's nothing you can do with that. You just get x minus 3. On the bottom, let's see, that's going to give me, I pull a 3 out, I end up with x squared minus 9. Well, that's going to factor. So I end up with x minus 3 over 3 times x plus 3, x minus 3. Right? So again, if you're confused about graphing, you should have this written down. You should have the problem written down, and then you factor. Now, once you've got all this factored, the very first thing you want to find out is you want to find out your vertical asymptotes and your holes. Right? I put those on the same line because you get the number the same way. How you find your vertical asymptote and holes is what makes the bottom 0. So you look at the bottom at this stage and you say, well, okay, what makes the bottom 0 for this is going to be a negative 3. So I'm going to put x equals negative 3. What makes the bottom 0 here is x is equal to 3. And so these are going to be vertical asymptotes or holes, and you have to decide what it is. Is it going to be a vertical asymptote or a hole? Well, how you decide is if it canceled. Notice that x minus 3 canceled that x minus 3. If something cancels, that means this, whatever x was part of the thing that caused it to cancel, this is a hole. If it doesn't cancel, it's a vertical asymptote. Right? So very first thing you do is, yes.
Oh wait, never mind.
Okay. The first thing you do when anytime you're given some sort of rational function, actually I probably should have a y equals all here, is you factor both top and bottom, and then ask yourself what makes the bottom 0. That gives you things that are going to be either vertical asymptotes or holes. Then you have to determine, is it a vertical asymptote or a hole? Well, most likely it's a vertical asymptote unless it gets canceled, and then it's going to be a hole. The next thing you want to find out is your horizontal asymptote. And your horizontal asymptote, that's what happens when x gets big, and that's when you talk about top heavy, bottom heavy, or balanced. So if it's top heavy, right? If it's top heavy, there's no horizontal asymptote. If it's balanced, we cancel stuff out. But in this case, it's bottom heavy. Notice you have an x squared on the bottom and an x on top. You have more x's on the bottom. It's bottom heavy. Anytime it's bottom heavy, you have a horizontal asymptote at y equals 0. So step 1, and I'm talking a lot, but it shouldn't take you very long to factor, determine your vertical asymptote, find out where the bottom is 0, determine if it's a hole or a vertical asymptote, and to find out your horizontal asymptote. That should be pretty quick. Your next step is you've got to draw a picture. Like as you find information, you want to draw a picture so you have some idea what this thing looks like. So it says we've got a vertical asymptote at negative 3. So that part's pretty easy. We have a horizontal asymptote at 0. Okay. So after we get our vertical asymptotes, holes, after we finish this part, the next thing we want to do is draw our asymptotes. Now, once you've got your asymptotes, or the framework, now you want to make an XY chart. You want to plot a couple of dots. You need to plot some points. And you want to pick points that are to the left and the right of your vertical asymptote. So what happens to the left? Let's see, if I pick something to the left, I'm going to pick negative 4. Something to the right, I'm going to pick negative 2. But I also want you to pick wherever your hole is. And since we have a hole at 3, we're going to pick 3. Okay. So how do you pick which points?
How do you determine which one is the hole and which one's the vertical asymptote?
If it got canceled out, notice the x equals 3. We got the x equals 3 from this part. Like why? Where?
Yeah.
Okay. And notice the x minus 3 is canceled out.
Yeah.
Whatever got canceled out, that's what caused the hole.
because it causes a problem, so it's...
Yeah, well, anything that causes a problem is going to be here. But if it gets canceled out, it's a whole.
Okay. Okay, thanks.
Okay. All right. So now we plot. Now, also, when you do some algebra and you simplify, like this is going to simplify, that cancels, this is going to give us a 1 over 3 times x plus 3. You always want to plot these x values into the cleaned up version of the function. I mean, technically you'll get the same answers if you plug them into the original, but it's a lot easier if you plug into the cleaned up version. And when I plug into the cleaned up version, let's see, that's negative 1 times 3, so I end up with a negative 1/3. If I plug 2...
Sorry, how did you find the vertical asymptote when you, for the x minus 3 over 3x squared minus 9?
So you had to factor the x squared minus 9.
Oh, okay.
Right? You have to continue factoring. Right? This whole... You've got it, and once you factor, then you'll have the x plus 3 and the x minus 3. Like what makes the 0 here is the negative 3. What makes the 0 here is the positive 3.
Okay. And so the one that cancels out is the whole.
Anything that cancels out causes a whole. If it doesn't cancel out, it's a vertical asymptote.
Okay, so there could be 2 vertical asymptotes?
Mm-hmm.
Okay.
Or there could be 2 holes. I mean, you could have you can have an infinite number of vertical asymptotes and an infinite number of holes. I'm not making you graph those right now because we're just learning how to do it. All right. So now I'm going to plug in a negative 2. So a negative, that's going to give me a 1 times 3. That's going to give me 1/3. And then I'm going to plug in a 3. And let's see, 6. That's going to give me a 1 over 18. So at this point, you should have your chart. You should have your graph. You should have your chart. And right now, the only thing we worry about plotting is the negative 4, negative 1/3, negative 2, 1/3, and the 3, 1/8. We get these values. Now we have to plot dots. So at negative 4, we're going to go negative 1/3. And to be honest, I'm not great at graphing 1/3. I just know it's a little bit below the x-axis, so I'm going to put my dot here. When I do negative 2, positive 1/3, I'm not great at plotting that either. I just know it's a little bit above. All right. Now the one part that's a little different than what I did on Friday, because I was feeling pretty rushed, is when you plot the whole, like you have to plot this. If you plot the point 3 and 1/18, well, it means you go over to 3, 1, 2, 3. 1/18, that's really small, so that's really just above the x-axis, but it's a whole. And since it's a whole, what I want you to do is put an open circle, right? Because it's a whole. Oh, Katie, I see your hands raised. Do you have a question?
Oh, sorry, that was for the question I asked earlier.
Oh, okay, all right. All right, so now, well, this is the most tedious part of this whole of the problem. We've got our dots, we've got our hole plotted. Now we need to draw our graph. And how we draw our graph is we put our pencil on the asymptote, and we have to hit all the dots. Like we hit the hole. Now we start on the asymptote, we hit the hole. Don't draw a line through the hole because it's supposed to be a hole, so we leave a gap. Then we hit this dot, and then based on where the dot is, that determines are we going to go up the wall or down the wall. And in this case, it looks like we're going up the wall. And then I put my pencil on the asymptote over here. I'm going to do a little swoopy thing to this dot, and this is going to go down the wall. And so I end up with my picture. So your main priority in rational functions is to generate this picture. Right? That's our job. Right? How do you get this picture? Well, let's see. You factor, and factoring helps you figure out what your vertical asymptotes or holes are. Helps you figure out what your horizontal asymptotes are. Draw those. After you draw those, you got to plot some points. You always plot a point to the left and right of the asymptote, and you also have to plot the hole. And then using that information, you can draw. Now on your homework, I ask a ton of information. It's like this giant block of stuff you're supposed to answer. So let's answer that giant block of stuff. Right? At the top of the list on that giant block is your domain and range. Right? Now your domain, those are places, those are legal x values. And if you look, we have an issue at negative 3 and positive 3. Those are the two places we have issues. So so if you think about it, you know, if you've got an issue, if I have an issue at negative 3 and positive 3, this is what we have to say in interval notation. So what we're going to do is say our domain goes from negative infinity to negative 3, then it goes from negative 3 to 3, then it goes from 3 to infinity. That's our domain. All right, next up, what's our range on this thing? And to be honest, the range on this is ugly, right? And here's why. For the most part, your range is everything. It goes all the way down, it goes all the way up. But we have two issues. We have two places, we have two y values that have problems. Right? And I want to talk about the y value that has problems. We have our y value of 0 is an issue. So if I'm looking at my number line going up and down, I have an issue at 0. Right? Okay, so we've talked about that before. What I haven't talked about is, oh, there's a hole here. And because there's a hole, that y value is 1 over 18. So there's actually an issue at the y value 1 over 18. And so when I'm writing my interval notation, it's everything from negative infinity to 0, from 0 to 1 over 18, and then from 1 over 18 all the way up. I'm not going to ask a question like that on your test, on your quizzes. Now, you'll get it next year in pre-cal, but I'm not going to ask that. But, I mean, these are the two y values that we have problems with. So now when we write this in interval notation, we go from negative infinity to 0, union 0 to 1 over 18, and then from 1 over 18 to infinity. That's kind of mean. All right. I think I've got x-intercepts in here because I think I've always that chart always includes x-intercepts. Well, for this one, it's easy. It never crosses the x-axis. If you look at your picture, x-intercepts, we're looking for where this thing crosses the x-axis. Never crosses. I mean, technically how you find them is you take the simplified version and set it equal to 0. Well, the only way a fraction ever equals 0 is if the top equals 0. And there's no way to make that 1 a 0, so there's no way for this to ever equal 0. So for x-intercepts, you've got none. I also have where is this thing increasing and where is this thing decreasing. Okay. Well, increasing and decreasing is as you go from left to right, are you going up or down? So as I go from left to right, I'm going downhill here, I'm going downhill here, and I keep going downhill. The problem is, so it's always going downhill, so there's no place where it's increasing. But where it's decreasing, it keeps breaking, like it has an issue at negative 3 and has an issue at positive 3. So where this thing is decreasing is from negative infinity to 0, negative infinity to negative 3, from negative 3 to positive 3, and then from 3 to infinity. Right? All right. So, and then the next thing I have is I have something called end behavior. What the heck is in behavior? Basically, in behavior is the same thing as your horizontal asymptote. In behavior is asking, what y value do we get close to as I go all the way to the right? What is my y value doing as I go all the way to the right? So as x goes to infinity, right, as I go all the way to the right, my y values get close to 0. Notice how my y values get close to 0. As x goes to negative infinity, as I go all the way to the left, my y values get close to 0. All right, so in practice, it doesn't take nearly as long to fill this part out as it did to actually teach it. This part is really just describing the picture. Where I want you to put most of your energy is come up with the picture. Once you have a picture, it's easier to describe this stuff. All right, now I need to hit pause. I need to stop.